Hello everyone, welcome back to my YouTube channel. I am Nishita SN, 4th SEM BE, Department of Electronics and Communication Engineering in Sri Venkateswara College of Engineering, Bangalore. In this video, I am going to discuss about the subject Principles of Communication System. In that, the topic is about amplitude modulation circuits in the diode modulators. First, we know about the introduction to AM circuits. Amplitude modulation circuits are a fundamental building blocks of radio and communication systems. These circuits are responsible for encoding information onto a high frequency carrier wave, allowing for the transmission and reception of signal over a long distances. At the heart of an AM system is the modulator, a device that takes the input signal and uses it to vary the amplitude of the carrier wave. This process is known as amplitude modulation, and it forms the basis for a wide range of applications from AM radio broadcasting to wireless telemetry and remote control systems. Amplitude modulation principle. In that first one, carrier wave. The carrier wave is a high frequency signal that acts as a backbone of the AM system. It is a constant amplitude, constant frequency signal that is used to transmit the information. Second one, modulating signal. The modulating signal is the information bearing signal such as audio or data that needs to be transmitted. The signal is used to vary the amplitude of the carrier wave. Third one, modulation process. During the modulation process, the amplitude of the carrier wave is varied in proportion to the instantaneous value of the modulating signal. This results in an AM signal that contains the original information encoded on the high frequency carrier. Next one is diode modulator. Basics, how it is works. The diode modulator is a simple yet effective amplitude modulation circuit. It uses a diode as the key component, which acts as a variable resistance. The input signal is applied to the diode, causing its resistance to fluctuate in response to the signal. This varying resistance in turn modulates the amplitude of the carrier wave, resulting in an AM output signal. Second, circuit configuration. The diode modulator circuit typically consists of carrier signal source, a diode, and a load resistor. The carrier signal is applied to the diode and the modulated output is taken across the load resistor. The input signal is also connected to the diode, causing its resistance to vary and thereby modulating the carrier wave. Advantages. Diode modulators are relatively simple and inexpensive to construct, making them a popular choice for many applications. They also offer good linearity and low distortion, making them well suited for voice and music transmission. Diode modulator circuit configuration. First one is circuit components. The diode modulator circuit consists of a carrier signal source, a diode, a load resistor, and the modulating signal input. The carrier signal is applied to the diode and the modulated output is taken across the load resistor. Second one is diode as a variable resistor. The key component in the diode modulator is the diode, which acts as a variable resistance. The modulating signal applied to the diode causes its resistance to fluctuate, which in turn modulates the amplitude of the carrier wave. Output signal. The output of the diode modulator is an AM signal where the amplitude of the carrier wave is varied in a proportion to the modulating signal. This AM signal can then be transmitted or further processed as needed. Biasing consideration. Proper biasing of the diode is crucial for the modulator to function correctly. The bias point must be chosen to ensure the diode operates in the desired region of its characteristics curve, which determines the linearity and efficiency of the modulation process. Sidebands and bandwidths. Sidebands. The amplitude modulation, the modulated signal consists of the original carrier frequency as well as two additional frequencies called sidebands. These sidebands are created by the mixing of the carrier and modulating signals. Second one is bandwidth. The bandwidth required for an AM signal is equal to twice the highest frequency of the modulating signal. This means that the total bandwidth occupied by the AM signal is equal to the carrier frequency pulse and minus the highest modulating frequency. Efficient spectrum utilization. The wide bandwidth required for AM signal means that the spectrum is used less effectively compared to other modulation techniques like frequency modulation. This is an important consideration when allocating limited radio frequency spectrum. Advantages, disadvantages and limitations of diode modulators. Advantages: simple and inexpensive circuit design, good linearity and low distortion, suitable for voice and music transmission, can operate at high frequencies, relatively low power consumption. Disadvantages: limited modulation depth compared to other techniques, susceptible to temperature variations and aging effect, potential for nonlinear behavior and harmonics generation, may require additional circuitry for proper biasing and stabilization. Limitations. One of the main disadvantages of diode modulation is its limited to modulated depth. The modulation index is typically lower compared to other modulation methods, resulting in a smaller dynamic range and reduced signal to noise ratio. Diode modulator can also introduce distortion, which can degrade the quality of the modulated signal. Efficiency. Diode modulators have relatively low power efficiency as a significant portion of the input power is dissipated in the diode. This can be concern in application where power consumption is a critical factor, such as in battery powered device or high power transmitters. Applications of AM circuits. First one, radio broadcasting. AM circuits are widely used in radio broadcasting where they modulate the amplitude of carrier wave to transmit audio signals. This allows for long-range transmissions of radio programs, making AM radio a popular choice for news, talk, and music stations. Second one, AM radio receivers. AM circuits are the foundations of AM radio receivers which demodulate the amplitude modulated signal to reproduce the original audio. These affordable and ubiquitous receivers are found in many consumer electronics from car, radio to portable devices. Third one is industrial application. AM circuits have applications in industrial control system where they can be used to transmit data and control signals over long distances. The simplicity and robustness of AM make it an choice for industrial automation monitoring. Applications of AM diode modulators. First one, AM radio broadcasting. Diode modulators are widely used in AM radio transmitter to encode audio signal onto the carrier wave for broadcast. Second one, remote control system. AM diode modulators are employed in various remote control applications such as garage door openers and toy controllers. Third one, wireless telemetry. Diode modulators are used in telemetry system to transmit sensor data and other information over wireless links. Fourth one, security systems. AM diode modulators are integral components in wireless security system, enabling the transmission of alarm signal and status updates. Conclusion and key takeaways. In conclusion, the AM circuit using diode modulation is a fundamental technique in radio communication. It allows for the efficient transmissions of information by modulating the amplitude of carrier signal. The key takeaways are the importance of understanding the modulation index, managing the bandwidth, and recognizing the advantages and limitations of this approach. With careful design and implementation, diode-based AM circuit can be leveraged in a variety of applications from radio broadcasting to industrial control systems. As we have explored, diode modulation offers a simple and cost-effective solutions for amplitude modulation, but it also comes with trade-offs that must be carefully considered. Moving forward, staying up to date with the latest advancements in this field and continuously improving the performance and efficiency of AM circuits will be crucial for meeting the evolving needs of modern communication system. Thank you for watching this video.